Patient. I'd like to introduce you to Matt Crowder, who will be your presenter today. Matt?
Thank you. Good morning. My name is Matt Crowder, and I'm a developer on the network team here at ESRI in Redlands. Joining me today is Derek Law, who is an instructor with the Educational Services team in Redlands. I'd like to welcome you to the Introduction to ArcGIS Network Analyst Training Seminar. Network Analyst is a new extension that will be released with ArcGIS 9.1. Before we get started, let's take a look at what we're going to cover in today's seminar. In the first topic, I'll explain what Network Analyst is and how it can be used within ArcGIS. Then, I'll talk in more detail about the various options and how they can be used to solve real-world problems. And finally, in the last topic, I'll go over the network dataset which stores the underlying connectivity. Today's format will include topic discussions and software demonstrations with question and answer sessions at regular intervals. Okay, so what is Network Analyst? In this section, I'm going to give you an overview of Network Analyst, talk about where it fits into the ArcGIS product line, and introduce you to some of the problems it can help solve. The goal of Network Analyst is to solve transportation analysis problems using data representing real-world conditions. Instead of just modeling simple streets like these, you can also model hierarchical road classes such as local roads, major roads, and interstates. Here, for example, the red line represents an interstate. You can also model multiple modes of transportation. So here we have streets, but we can add a light rail represented by the white line, and multiple bus routes represented by the yellow and blue lines. With Network Analyst, it's possible to jump from one mode to another mode at various locations like ramps, bus stops, and rail stations. In addition, you can model turns to restrict or penalize travel through a set of features. If we look at the functionality in Network Analyst, we find that components from other ESRI routing technologies have been included in it. For example, Network Analyst supports models or scripts similar to functionality found in ArcInfo Workstation. There are user interface components similar to those in ArcView 3x, which allow users to graphically perform analysis. You can access the network programmatically, like with NetEngine. Parts of ArcLogistics route, like time windows, are included to help solve complex routing problems. And finally, ArcGIS Server with network extension provides a platform to perform analysis on the web similar to ArcIMS Route Server. As Network Analyst matures, even more functionality will be added. So the next question many people may be asking is, what kinds of problems does Network Analyst solve? For the initial release, it will perform 4 main types of analysis. The best route algorithm allows you to find the best route between a series of stops in the order you specified, or you can reorder the stops to find the best order for you. The closest facility algorithm allows you to find the closest facilities for one or more incidents. This is for things like finding the 3 closest fire stations to a fire. You can generate service area polygons and lines to find the area and streets traversed within a specific time or distance from a location. And using the origin destination cost matrix algorithm, you can create time distance tables from one set of locations to another set of locations. Network Analyst was designed to be used throughout the ArcGIS product line. In ArcGIS Desktop, including ArcView, ArcEditor, and ArcInfo, it can be used inside ArcMap to leverage the other tools within ArcMap and through geoprocessing to automate tasks. A network extension that is licensed separately from ArcGIS Network Analyst is available for ArcGIS Server and ArcGIS Engine. The network extension for ArcGIS Server allows web developers to build server-based applications that perform network analysis. The network extension for ArcGIS Engine allows developers to build custom desktop applications for network analysis. So let's take a closer look at this. In ArcMap 9.1, you use Network Analyst as an extension. Those of you out there with experience in ArcView 3x will recognize some similarities here. It works with layers just like everything else in ArcGIS. With Network Analyst, there is also a new type of layer called a network analysis layer. Network analysis layers hold the properties of the network problem that is being solved. This includes the network locations like stops and barriers, the resulting route or service area, and all the other settings that are part of the analysis, like the cost attribute, the restrictions, and much more. Since network analysis layers are ordinary layers, you can change their symbology or other properties, as well as use them for other spatial analysis within ArcGIS. When you want to work with your network analysis layers, you'll use the Network Analyst toolbar. On it, you'll find tools that let you add network locations like stops and barriers, generate routes, and generate directions. There are also tools that let you query and build the underlying network dataset. Finally, there is a Network Analyst window, which gives you a convenient way to manage your network locations like stops and barriers. For example, if you want to reorder your stops, you just drag and drop them in this window. I'll show you this in the demo in just a minute. Network Analyst can also be driven by all of geoprocessing, including models, scripts, and the command line. For those of you running the same analysis over and over with different data, like daily route generation for multiple vehicles, geoprocessing is a great way to automate these repetitive tasks. Network Analyst in the geoprocessing environment is also especially useful when the network analyst is only one small part of a much larger problem that is defined in a model. For example, you may have a large model that performs flooding analysis and may wish to include another small part that simply checks how accessibility changes based on flood conditions. Geoprocessing can also be used in conjunction with the network analyst tools within ArcMap through the Arc toolbox. For example, you can do most of your work in ArcMap and use Arc Toolbox to access Model Builder or scripting for the mundane, repetitive tasks. This will save you time typing and ensures consistency. Network Analyst functionality can also be embedded into web applications using ArcGIS Server with the network extension. The ArcGIS Network Server extension supports both intranet and intranet requirements and allows you to serve a large group of people performing network-based spatial analysis within a scalable and IT-compliant framework. There are several ways of exposing network analysis on the web. Examples include publishing ArcGIS map server objects that contain network analyst layers, publishing SOAP web services that accept input parameters, perform specific network-based spatial analysis with Arc objects, and return non-graphic result sets, or custom web services or web applications that return maps and directions. Using ArcGIS Engine, network-based spatial analysis can be embedded within lightweight custom applications with a network extension. This is useful when you have a very specialized, streamlined application or when you just want to embed network analysis into a non-GIS application. All major programming languages are supported, including Visual Basic, C++, .NET, and Java. Okay, let me take you on a quick demonstration to show you how the network analyst can be used in ArcGIS. To start, let me bring up ArcMap and walk you through the various components of the network analyst in ArcMap. Here you see I've opened ArcMap and we already have some data loaded into it. This data represents the Bay Area around San Francisco, and you can see streets, some other land base, and the ocean. You can also see we have some additional UI controls. Here, for example, is the Network Analyst toolbar that I mentioned earlier. Here is the Network Analyst window, which is a dockable window that holds the results of your analysis. And here is a Network Analyst layer. In this case, it's a route layer. Using the Network Analyst toolbar, let me create a new route layer. I'll do that by clicking on Network Analyst and clicking on New Route. As you can see, when I created a new route layer, it got added to my Maps table of contents, and also it appears down below in the Network Analyst window. You can use this to switch between other analysis layers in your map. Let me use the Create Network Location tool, and I'll click on the screen to see how I've added a stop both on the screen and that's reflected in the Network Analyst window as well. I'll add a couple other stops. Then using the Network Analyst toolbar, I'll click on Solve to generate a route between those three stops. I can additionally add more stops, and in this case you see it's unlocated because it's not within a spatial reference of a feature. Let me undo that, possibly add another location, resolve, and you can see a route's been generated. I can also use the Network Analyst window to pick up a location and drag it to another position in the stops window. So in this case, now my graphic pick 5 will be the first stop in my list, and when I solve, you'll see a new route generated based on the new positioning of the routes. I can also use Arc Toolbox. In this case, I've created a model already that does network analysis. Let me open up that model and walk through it real quickly. Here you see we make a new route layer, and then we'll add locations to it, in this case stops with time windows from a feature class, and then we'll solve that network analysis. Let me click Run to perform the analysis, and when I'm done and close the model, you'll see that a route's been added to my map and it's performed the analysis on the screen. Once this is done, I can continue working with it like any other layer in map, doing things like adding more stops or repositioning them as well. I can also remove analysis layers from my map at any time. I'd also like to show a simple Arc Engine application to show how Network Analyst can be embedded within it. In this case, this is a simple Visual Basic application where I can type in breaks and find the service areas, which would be the amount of distance I can travel within 1, 2, 3 minutes from each of these facilities. I can of course change that to be 4 and 2 to find the streets that can be traveled in 2 and 4 minutes as well. This is a very simple application just to demonstrate that basically Network Analyst can be performed in ArcMap or in any custom application where it's either a major component or even just a minor component of it. Okay, so in this topic I talked about Network Analyst extension and some of the ways that it can help solve real-world problems dealing with transportation. I also explained how Network Analyst can work within the complete ArcGIS product line. Let me turn things over to Derek for a few minutes so he can answer some of your questions. Derek?
Thanks, Matt. First, we have a question from Ann in Washington. Will the Network Analyst extension work with existing ArcGIS 3X network data? And the answer is yes. Networks that were built in ArcGIS 3X used shapefiles, and you can use these shapefiles as network sources to create your own new network data set within ArcGIS 9.1. And you can take advantage of the new model by incorporating new network attributes for advanced capability. Next, we have a question from Greg in Portland. What is the difference between the Network Analyst extension and Utility Network Analyst, the toolbar in ArcMap? For those of you who are unaware, in previous versions of ArcGIS, we had some network analysis functionality with a toolbar inside ArcMap called Utility Network Analyst. And this toolbar utilized geometric networks. And primarily the application was designed for utility network systems, such as river systems or gas and pipelines. Network Analyst, on the other hand, is an extension new to ArcGIS 9.1 that works with network data sets. And this really is used for transportation application systems, so something such as a street network. Finally, we have a question from Mike in Denver. Can the Network Analyst extension use geometric networks? And no, the Network Analyst extension is really designed for network data sets. Now, if you want to use feature classes that participate in a geometric network, you can certainly delete your geometric network or make a copy of those feature classes and then create a brand new network data set. Matt?
Okay, thanks. So in the last section, I quickly described the types of analysis that ArcGIS Network Analyst can perform. Now, let's take a more detailed look at the functionality in each type of network analysis. One of the most common uses of Network Analyst is finding the best route. This finds the route that minimizes the travel cost through a series of stops. When finding the best route, you can set several options. You can change the cost attribute for which you're minimizing travel expense. For example, you can use normal driving times or switch to driving times during rush hour. You can also accumulate additional costs like both miles and minutes. You can use a specified order of stops to find the route or have it reorder the stops to find an optimal route for you. This is known as the traveling salesperson problem. You can use time windows during analysis to specify the valid time of day to reach each individual stop. You can add additional cost at each stop representing service time, unloading time, and other forms of wait time. You can also get turn-by-turn directions for the route. Let me show you some of these operations in action. So here I'm back in ArcMap, and you can see I already have a route layer added to my map. Let me right-click on the stops in the Network Analyst window and load some stops in. In this case, I'm going to choose a feature class pre-created where I have stops predefined with time windows and a sequence in which I want to visit them. Let me choose the sequence field to order by, and as I add these locations, you see they appear on the screen, and they also appear in my Network Analyst window as well. When I click Solve, you'll see a route is generated between those 5 stops. As you can see, this is a less than optimal route because I'm going from my first stop up here to my second stop down here based on the sequence I had specified. I might want to have these resequenced for me by the solver. By doing so, I clicked on the Network Analysis layer properties, and I want to click on Reorder Stops to find optimal route. In this case, I'll preserve the first stop for me. Now, when I resolve, you'll see the route changes to find the best route between the stops in the order determined by the solver. Once again, let me bring up the properties, and I'd like to use time windows. Now, time windows specify that those stops can only be reached at certain periods of time. So if we use time windows and we don't have the solver determine the best order for me when I solve the route, you'll see that 3 of these stops show a red square symbolizing that they have a time violation. Let me use the Identify tool to identify one of these stops, and you can see that the time window is between 8 to 9 in the morning, yet I didn't arrive at that stop until 11 o'clock. That's why it's in violation. Let me close the Identify window, re-bring up the properties, and change to reorder the stops to find the optimal route for me. In this case, it'll use both the spatial constraints and the time window constraints when finding the order. So when I click Solve, the route generated will find the best route using both of those constraints. Another use of Network Analyst is finding the closest facilities to one or more incidents. This is commonly used for emergency vehicle dispatch because it finds the route that minimizes the travel costs between each incident and facility. You might also use this to find routes between patients and healthcare providers, customers and stores, or to find the 3 closest ATMs to a person. Once again, there are several options you can set depending on your situation. You can change the cost attribute, so just like in the best route solver, you can use normal driving times or rush hour driving times. You can also change the number of facilities you want to find and specify the cutoff value at which point you stop trying to find facilities. For example, only find the 3 closest facilities that are within 10 minutes of an incident. You can also specify the travel direction so that the route is from the facility to the incident or from the incident to the facility. You can add costs on the incidents or facilities to represent additional time spent at either the beginning or the end of the route. And again, just like with the best route solver, you can generate directions for the routes between an incident and a facility. Let's take a quick look at the options you can set for the driving directions, and then I'll be back to demonstrate how to use the closest facility in ArcMap. So like I mentioned, driving directions can be generated based on the results of the best route or the closest facility network analysis. You can choose to display turn-by-turn inset maps. You can also change the distance units to something other than those of the cost attribute. So for example, even if your network attribute is in miles, you can still display travel directions in kilometers. And you also have the option of printing overview or turn-by-turn maps. So let me bring up ArcMap and show how you can use the closest facility solver, and I'll generate the driving directions for the route it finds. So back in ArcMap, let me change to a different map, and you can see this already has a closest facility analysis layer in it that includes 9 network locations representing hospitals. You can see I've changed the symbology to show a hospital symbol. Since these analysis layers are regular feature layers, you can change the symbology to anything that ArcMap supports. Now, from these hospitals, I want to find the 3 closest hospitals to my house. So with my house representing an incident, I'm going to use the Find tool and type in my address. And you'll note that it finds my address, and I can right-click on that and add that as a network location. You'll see as I do so, that incident is now populated here and on the screen. When I click Solve, it will find the 3 closest facilities from my house, that is the 3 closest hospitals, and generate routes to each one of those. Those appear in the Network Analyst window as well. For any one of these, I can right-click on it and show the directions. Or if none are selected, I can click and show the directions for all of them. There's other options I can set for this as well. For example, I might want to find the 7 closest hospitals, but only those that I can reach within 5 minutes. When I solve this problem, you can see that only 6 routes were generated. That's because there were only 6 that fell within that time constraint. Another option I might want to change is to, instead of seeing the true shape of the route, I might just want to see a straight line going from each incident to each facility. By changing that option and resolving, the routes are represented by straight lines going between the 2. Another analysis you can do with Network Analyst is finding service areas. For example, the area that can be traveled within 30 minutes from a given location. This is used when you have 1 or more locations and you want to determine the lines or area that can be traversed within a specified cost. The result is the lines traversed and 1 or more polygons around those lines. With this solver, there are options to change the break values. Breaks are the cutoff costs that you want to use when calculating the service areas. You can specify multiple breaks either globally or for each facility. For example, you can create polygons at 5, 10, 15-minute intervals. You can also set the direction of travel to either to or from the facility. You have several polygon options. You can create separate polygons for each facility or merge the same ranges between facilities. Also, you can create closed polygons representing the total area from each location to the break, or you can create ring polygons that represent the area from the previous break to the current break. For example, you can create 1 polygon that represents the area that can be located 3 to 5 minutes away from any hospital. There are several line options, such as generate lines with ends, lines that are explicitly split at breaks, and either all the lines or non-overlapping lines from the closest location. Some common uses of the service area algorithm are fire response zones, customer service areas, and generating accessibility maps. If I bring back up ArcMap, let me switch to another map that contains a service area layer. As you can see, I'm using the same 9 hospitals, and I've already calculated service areas around these hospitals at 1, 2, 3, 4, 5-minute intervals. So for example, if I select the 0 to 1 minute ring, that represents the area I can get to within 1 minute of a hospital. The 1 to 2 minute ring represents the area that I can reach between 1 and 2 minutes of the hospital. Let me close this service area layer and add another one that we can do some additional analysis on. So for example, let me simply add a couple of service area lines, a couple of facilities, and click Solve. By default, it'll generate one service area for each facility traveling out in 5 minutes if you have a cost attribute of time. As you can see, the result is 2 polygons, one for this facility and one for this facility. Now let's see some of the options we can change. Instead of having just one break of 5 minutes, let's once again change it to be multiple breaks of say 1, 2, and 3. For some polygon options, let's merge the polygons like on the previous example and see what the result might look like. When we solve, you'll now notice that we now have polygons merged for the different breaks. As you can see, for this middle break, there's holes in the middle because it's rings representing an area that can only be traveled between 1 and 2 minutes. If you wanted discs representing from the facility to the end of that break, you would change it to a disc option, where now the single break would be here. The larger break would include the encompassing area. Once again, the 0 to 3 would be the entire polygon. Other options you can specify are for lines. For example, let's generate lines where we split the lines at the break values and we'll have them non-overlapping. By choosing this, this will only create lines for the street based on the closest facility from that street. So if I resolve, in this case, it will generate both polygons and lines. By default, the lines generated will all be symbolized with the same symbol, but since this is ArcMap, I can change the symbology like any other layer. In this case, let's render our facilities based on the unique facility ID. And we'll add all the values, click OK, and you can see by the result that the streets shown represent the streets that can be traversed from the closest facility. Okay, the last type of analysis I'm going to talk about is generating origin-destination cost matrices. This generates a table of the cost going from each origin location to each destination location. The result can be used for such things as spider diagrams or distance time charts. With this solver, you can change the cutoff value either globally or for each origin, and you can change the number of destinations defined, again, using either a global setting or for each origin. If we go back into ArcMap and change to an origin-destination cost matrix map, you can see I've pre-populated an origin cost matrix with 5 origins and those same 5 locations as destinations. When we click Solve, this will create a full matrix from each origin to each destination. As you can see, it takes more time to go in one direction than the other. There are several options we can change. For example, in this direction it might take 9.8 minutes, in the other direction 12 minutes. What would happen if we specify cutoff value of 10 minutes? You'll notice that there should only be one here, and a lot of these other distances that are greater, it should not find a route between those two. When we click Solve, you'll see that that's exactly what happens. There are also other options that can be specified when performing network analysis, so let me quickly mention these as well. You can add barriers to prevent traveling across particular edges. These barriers can be loaded from features or added graphically using the Network Analyst toolbar. You can set a U-turn policy which specifies where a route can reverse direction, for example, only at dead ends. The curb approach lets you specify which side of a street the route should arrive on at a location. Options include right-hand side, left-hand side, or either. This is useful for things like bus routing. Restrictions are additional attributes on the network that restrict traversing specific streets, things like one-way streets, weight restrictions, or time-of-day restriction attributes. And for the best route, closest facility, and origin-destination cost matrix solvers, you can specify to use a hierarchical algorithm if your data supports hierarchies. A hierarchy specifies the streets into three groups: interstates, major roads, and local roads. The hierarchical algorithm attempts to get on the larger roads and stay on the larger roads. Not only does this improve analysis times, but it also offers more realistic routes when people prefer driving on larger roads. Let me go back into ArcMap and change to another map where we can see I've pre-created a route layer where I've added two stops to it, one representing a start point and one representing an end point. If I click Solve, you'll see it will generate a route on the local streets going between the 2 points. Now I may want to change my routing to use a hierarchy. If we look at the hierarchy ranges, it shows that there are 3 classifications: local roads, secondary roads, and primary roads, where the goal is to try and get on the higher level roads like the primary roads and stay on those as long as possible. In this case, since I'm using a hierarchy and I click Solve, you'll see the route changes to get on the higher level road, which is the major road, and travel down that as long as possible before getting on the service streets. Let me show you some of the other options. So for example, let me get the magnifier tool and zoom in on a smaller area. Now if I click on the barriers node of the Network Analyst window and use the Create Network Location tool, I can add barriers anywhere on the network. As I do so and click Solve, you'll see how the route changes to avoid those areas. This is because barriers placed on streets restrict those streets and make them non-traversable. Thereby, when you generate routes, it will avoid those areas. Let me zoom to another area to show some other options. In this case, let me zoom in even more. Here you can see our second point ends up on the right-hand side of the road. After this point, let's add another one on the left-hand side of the road. When I click Solve, you'll see the route now continues past the second stop, turns right at the street, and ends at the third stop. Well, it might be the case that I only want to reach this third stop with it being on my right-hand side of the street. For example, I might be a bus. Let me right-click on the stop, bring up the properties of it, and you can see there are a lot of properties. I'd like to change the curb approach to be right-hand side of vehicle. By doing this, I'm specifying that I must reach the stop with it on my right-hand side. When I resolve, you see the route changes, so I turn right onto Northwood, do a U-turn at the intersection, and turn back around to reach stop 3. Well, maybe since I'm a bus, I don't allow U-turns as well. Let me change the properties of the analysis to something else, and I'll specify I don't allow U-turns anywhere. By doing so and resolving, you'll see how the route changes yet once again, where I continue on to Route 2, loop around this intersection, and then turn and finally arrive at stop 3. Now, while this wouldn't be advisable for a bus routing application, for an emergency vehicle application, you might not want to have a one-way restriction checked. In this case, before we had traveled the right way on a one-way street, but here we've turned off that restriction, and you can see when we resolved, the route will now generate a route irregardless of the travel direction based on that restriction, but still respect things like the curb approach, etc. Okay, so now you've seen each of the Network Analyst solvers. I want to see if you've been paying attention. Locate the review question link in the upper left corner of your browser window and click on this link now. Okay, here's the question. Let's say you want to determine all the customers that can travel to a store within 15 minutes. What solver would you use? Would you use best route, closest facility, service area, or OD cost matrix? To submit your answer, click A, B, C, or D, then click the Send button. We're going to do a quick review and answer some of your questions first, and then we'll see how many of you answered this correctly. Okay, in this topic, I talked about 4 solvers that will be released with Network Analyst 9.1. Each of these solvers have different parameters you can set, such as cutoff values, restrictions, and barriers, which all affect the analysis. Now let me turn things back over to Derek so he can take some of your questions. Derek?
Thanks, Matt. First, we have a question from Nicholas in Valley Center. Can Network Analyst be utilized for analysis without ArcEditor or ArcInfo? In other words, if I have the Network Analyst extension, can I do analysis and generate network data sets with just the ArcView level of ArcGIS? And the answer is absolutely yes. Alan in San Antonio asks, is the Network Analyst a good tool for meter reading routes? An average route is about 500 meters per day. And the answer is yes, of course. You can use Network Analyst to determine routes from reading meters. A good suggestion would be to store all your different meters as a point feature class. Jonathan in Chapel Hill asks, when will this extension be available? The Network Analyst extension will be released with ArcGIS 9.1. Finally, we have a question from Heather in Lacey. What type of attributes are needed in your base data in order to use Network Analyst? You can use any shapefiles or feature classes to generate a network dataset. However, if you want to perform network analysis, it's probably a good idea to have one of 4 different types of specific network attributes that Matt will talk about in the upcoming section. They are cost attributes, descriptor attributes, hierarchy attributes, and restriction attributes. And you can use these attributes as parameters to control your analytical results. Back to you, Matt.
All right, thanks, Derek. Let me answer a couple more questions. Britt from St. Clair Shores asks, what will Network Analyst provide that NetEngine does not? Network Analyst does support ArcEngine applications, so anything that can be done with the functionality you'll see today can be done with the Network Analyst in an engine environment. The advantages would be an enhanced data model and the ability to add additional solvers as well. Another question by Michael and Charlotte asks, can you do multiple vehicle routing with Network Analyst, such as in ArcLogistics Route? ArcLogistics Route actually has a different solver that at the first release of Network Analyst is not going to be included. You can certainly do multiple vehicle routing, but it won't be exactly the same as ArcLogistics Route at this time. Okay, let's take a look at the results of the first review question. We wanted to know which solvers you would want to use if you wanted to find all the customers that can travel to a store within 15 minutes. And the correct answer is C, the service area solver. It looks like about 68% of you answered it correctly. Remember, the service area solver travels out in all directions from a location and returns the streets that could be traversed within a specific amount of time or distance. Okay, in this final topic, I'm going to introduce network data sets. I'll go over what they are, where they can be located, and some of the functionality that they expose. Keep in mind that this is just to give you an overview. We are not going to go into a lot of detail. At the end of this session, I will give a demo of using a multimodal network using streets and subways, and will then show the properties of that network. So what is a network data set? A network data set is a new type of data set similar to a geometric network or topology, where it is a higher level data set referencing other feature classes in the database. In the case of the network data set, it holds a network built from simple point-and-line feature classes. It was designed to work especially for the Network Analyst extension. When you work in ArcMap or ArcCatalog, you'll see it in the table of contents just like your other data sets with an icon that looks like this. Network datasets can be defined on a variety of different data sources. This includes both personal and ArcSDE geodatabases. In geodatabases, a network dataset can hold an unlimited number of line, point, and turn feature classes. Network datasets can also work with shapefiles. Like ArcView 3X, they are limited to one line and one turn feature class. In addition, SEC databases with networks, for example those used by StreetMap, will appear as read-only network datasets in ArcGIS. The network dataset is designed to accurately support and model transportation networks. To do that, it has some enhanced modeling capabilities. We'll take a closer look at these capabilities in a few moments. But first, let's see what makes up a network dataset. A network dataset maintains a connectivity graph of junctions and their connected edges and feature classes in the databases. These feature classes are called sources. Line features define one or more edge elements going between junctions. Point features define junction elements. Wherever an edge ends and there is no explicit point feature, a system junction will be created automatically. There are also turn features. Turn features are really simple line features with specific fields, and they define turn elements. Turns model explicit transitions between two or more edge elements. They specify that traversing a specific set of edges is restricted or has specific costs. For example, a turn may model that a specific intersection does not allow U-turns, or that a specific turn takes 5 minutes. You can create these turn features using ArcMap's editing tools, or you can import them from an existing ESRI turn table. It is also possible to define default turns without having to create turn features. Default turns are not explicit turns, but rather are used to specify restrictions or costs where an explicit turn does not exist. For example, all left-hand turns cost 15 seconds. Turns are not limited to being between only two edges, but can specify maneuvers between any number of edges. Network attributes are similar to fields in feature classes or to network weights that are inside a geometric network. They represent values on each element that's part of the network. There are several different types of network attributes. Cost attributes, for example distance and time, are accumulated as you traverse a network element and are apportioned if you only traverse through part of an edge. Descriptor attributes are used to describe things like the number of lanes and are not apportioned or accumulated. Restriction attributes are Boolean conditions that restrict traversability in one or both directions of a street. For example, a one-way restriction may restrict traversal in one direction of a street. Hierarchy attributes, as mentioned earlier, classify the network elements into different classes. These classes can then be grouped into 3 hierarchical groups representing highways, major roads, and local roads. So what are these attributes used for? Well, they control the navigation during network analysis. They may be used to accumulate information like total amount of minutes or miles traversed. A network dataset has a sophisticated connectivity model to allow users to more accurately model transportation networks. It defines how different source feature classes in the network dataset connect to each other. There are different connectivity options that you can set depending on the format of your data. One connectivity option is to specify that connectivity is only established at endpoints of features. This may be preferred if the data is non-planarized and 2 lines may cross each other, but you do not want them to connect, like in an underpass-overpass situation. The alternative is to allow connectivity between vertices of features, similar to how complex edges in a geometric network works. So for example, here you can see we have 2 street features that share an intermediate vertice. If we specify endpoint connectivity, this would represent that even though those 2 streets cross each other, they are not connected. with any vertex connectivity, since we specified that any vertex would connect them and they share a vertex, it would represent that you can traverse from one street to the other street at that vertex. Another option is to use z-elevation fields, also known as z-levs. Z-elevation fields are used with data where multiple features may share a common endpoint, but those endpoints don't necessarily dictate connectivity. For example, in underpass-overpass situations, z-levs may be used to specify the level each endpoint represents. Only features sharing the same endpoint and the same z-lev are connected. So in this example, once again, we have one road going this way and we have another road going this way, but the data is modeled as separate road features where all four of those features are connected at one location. These features can represent different levels by 1 and 2, such that during the build process, the build knows that the green lines should be connected and the orange lines should be connected, but they should not all be connected together. Thus, you can represent an overpass-underpass situation. You can also use connectivity groups to model multimodal networks. You segment the network sources into various connectivity groups, for example, streets, buses, light rails. Then you define points that act as transition points between the groups, for example, bus stops and rail stations. This will allow you to continue on one connectivity group until you reach a transition point where you then may transfer to another mode of transportation. Since we've talked a lot about multimodal networks, I'd like to really demonstrate this in action. So let me bring up ArcMap and switch to a different map document with a multimodal network. In this case, this is a Paris data set that includes both streets represented by the gray lines and the subway represented by the larger colored lines. The points along the lines represent subway entrances where you can get from the street to the subway. Now, if I click Solve, you'll see a route generated between my two stops, and it, for the most part, takes the subway. Let me zoom in a little bit so we can look at this in more detail. So here you see we start on a street and we walk until we get to a subway. If I hide the route for a minute, you can see we transcend to a metro entrance where we then travel along to get to a metro station. Then once we have a metro station, we go along the metro until we get to another location where we travel between another metro station to another metro station, where we get back on, travel down, where we get off the metro station, get back on a road, and finally walk to our other destination. We were able to do this traversal because in our network data set, we had set up an impedance attribute based on pedestrian time, how long it took to traverse those metro lines and those streets based on travel time of a person walking or riding the lines. We've also set up this network to do it based on drive times. So for example, I can change to use the drive time attribute, specify I want to respect the one-way restriction since I'm driving now, and click OK. When I solve, you see my route now is determined based on driving. I can also further modify my route to say use a hierarchy to give me a more accurate representation of how I might drive that route. So given that analysis, how is that set up in the database? Let me quickly bring up our catalog and right-click on the Paris network dataset and bring up the properties of it. Here you can see the sources that compose that network dataset. We have the metro lines, which is a line feature class representing edges, which are the subways in my network. We have streets, which represent the streets. We have transfer stations that go between metro stations, and we have transfer street stations, which represent going between a street and the metro station. We also have metro entrances, metro stations, etc. Now the connectivity of this is important. As you can see, we have two connectivity groups. In the first group, we have our metro lines, our metro entrances, stations, and the other edges going between those two. Now what this represents is traveling along the metro, the subway. In our second connectivity group, you can see that we have our streets and once again the metro entrance. The metro entrances are important because that provides the transition point between where I travel from a street to get on the metros and between the metro to get back on the street. As far as the solve times, if we look at the attributes, for driving we use the drive time attribute. If we look at this, we see for the streets there's a value set on those features representing the amount of time it takes to travel on each one of those streets. For all the other sources, like the transfer stations and metro lines, it's represented by -1, meaning that you can't travel on those features. This is important because you can't drive on a metro line. If we change this to something like pedestrian time, you can see that the attribute values change. For most of the features, it's represented by a real calculated value on the metro lines and transfer stations. And for the streets, it's represented by an expression. If we show what that expression is, it shows it's meters times 60 divided by 3,000. That represents 3 kilometers per hour, and that's the speed that we can walk on those. Okay, since we've talked a lot, in this topic we talked about network data sets and how they help you accurately model transportation networks. We also talked about network sources that make it up. Now let me turn things back over to Derek so he can take some of your questions. Derek?
Thanks again, Matt. Thomas in Augusta has a question. Can you utilize speed limits in cost attributes for a network data set? And the answer is absolutely yes. Christopher in New York City asks, can origin-destination data be exported to other database applications such as Excel or Microsoft Access? And the answer is yes. After you've generated your origin-destination matrix results, what you can do is access the layer and open up its attribute table in ArcMap. Then, like any other table in ArcMap, simply export it to the desired application. And finally, we have a question from Tim in Halifax. Can a feature class participate in a topology and a network data set? And the answer is yes. A feature class can exist in both data structures. Back to you, Matt.
Thanks. Let me answer a couple more questions. Can I create multiple routes from one analysis? For example, make 5 routes between these 50 locations. There are several ways you might want to accomplish that. One, you can use the route solver within a model to generate multiple routes and accumulate those together in a feature class. Or you could use the closest facility solver to have 5 incidents and maybe the 50 locations and generate routes between all of those. Or you could use an origin destination cost matrix network. Another question from Steve in Sheridan is, will network analysts do trash pickup routing where you have to hit every house on both sides of the street? This is also known as the Chinese postman problem, and in the first release we won't be supporting this, but since we do allow writing custom solvers, this is something a business partner might choose to do as well. Another question from Mark in Vancouver is, what steps are required to prepare your data for use in Network Analyst? The steps really depend on your data. If you're coming from ArcView 3X, it should be a matter of just accepting the defaults as you build your network data set, and it should pick up the attribute values for you. Otherwise, you may want to go through some of the tutorials to understand what the attributes mean and how it makes sense to best model your data. Okay, it looks like we're out of time. There are several resources available where you can find more information about the Network Analyst extension. Online resources are available at www.esri.com/networkanalyst, where you can find detailed product information and demos. Users with maintenance on ArcView, ArcEditor, or ArcInfo will be shipped the ArcGIS 9.1 update in May. Once installed, you can evaluate ArcGIS Network Analyst for 60 days at no additional cost. Otherwise, you will be able to order the ArcView 9.1 Evaluation CD at no cost from the web page once it becomes available this summer. This CD contains a 60-day evaluation version of ArcView 9.1 and the ArcGIS extensions including ArcGIS Network Analyst. There is also a very good Network Analyst tutorial available on the ESRI Software Documentation Library CD that comes out of the box with 9.1. This hands-on tutorial walks you through creating network datasets, using each of the solvers, as well as creating a model for route analysis. The desktop help has a help book devoted to the Network Analyst extension, and you can find lots of information there. Those of you who are programmers will probably be interested in the developer samples that are provided in the software development kit. The samples include code as well as DLLs. On behalf of ESRI, I'd like to thank you all for attending.